Hello everybody and welcome to another video here at TD Channel. Today we're gonna start covering one of the most sought after languages right now in the industry, and it's also the language that I enjoy the most to teach and to develop software in. The name of this language is Python, and if you've been in this industry long enough, you've heard it probably all over the place. So if you've always wanted to learn it but been a little bit intimidated by it, don't worry, because Python is pretty much the perfect language for someone who's never programmed before, who wants to get into programming. So let's get started with this. So let's think about what Python is for a minute. And as you start to program, probably a lot of people start thinking, wouldn't it be cool if there was a simple to learn yet powerful programming language? That this language was backed by a huge community, so it was very easy to find recipes on how to do stuff. That there were hundreds of modules out there that you could just download, put into your system, and then suddenly, instead of having to spend hours developing something, you can just use the work that other people have done, and they have very gracefully donated for the industry. And finally, that this language was pretty much supported by every major CG production package out there. Well, guess what? There is such a language, and it is called Python. So let's go really quick over the top 10 reasons why Python rocks and why I think that Python, these are the reasons why Python has slowly but very steadily taken over the industry as the main programming language. Well, first of all, it is very simple. It has a very simple syntax, and with very little lines of code you can accomplish a lot. Another reason, it provides automatic modules and namespaces, which means, and you'll see this as we start working, but in other languages you have to think ahead of time if you're trying to build a module or if you're trying to build a library. In library, any file that you're working in can pretty much be automatically imported as a library to another script, and this is a very powerful way of working, and a lot of times it just saves you time that it does that automatically. 3 is a fully object-oriented language which allows you to program in classes. This is something that we're going to cover in the future, and is extremely powerful, especially if you're trying to translate problems from the real-world domain to the computer domain. Don't get baffled or flustered by any words that I'm throwing out there right now. It will be quite easy to understand, and once you get it, you'll probably think, how did I ever get any work done in scripting without objects? Number 4, there's a huge community with great support out there. Like I mentioned earlier, there's hundreds of websites that have all kinds of recipes and problem solving and snippets on how to do stuff with Python. Number 5, there's modules for pretty much everything that you might need to do out there. And if there's no such a module, maybe you can create it and donate it out into the, into the open source community. Number 6, Python is pretty much 99% cross-platform. And what I mean by this is that, you can pretty much take any Python script and running on most operating systems. And if the script was written the proper way, it should be able to run. There are very few calls in the Python language that just will not work under all operating systems, especially like Windows is the one that it usually has a hard time with. There are certain calls that are available for Windows that are not available for the other OSs, or vice versa. But overall, I think a good 98 to 99% of it is cross-platform. 7, it has an interactive shell. So you can open a shell, type the word Python, and now everything you type in there can be executed and evaluated as Python code. So this is really cool when you're trying to figure out, or when you're trying to learn something. We're going to see the interactive shell in this first video, so you guys will see what I'm talking about. Number 8, it is very easy to embed and to extend. What I mean by this is, if you had a software package and you wanted to embed Python to it as a scripting language, it's not hard to do. Actually, a lot of software has done it after the software was initially released. They just, as Python became more popular, they're like, hey, we probably need to embed Python. That's what they have done. That's what Maya did, for example, and Houdini did. Number 9, it's supported by Maya, Houdini, Nuke, XSI, Blender. Digital Fusion, RenderMan, Arnold, pretty much every major CG application out there supports Python as a scripting language. So here you have a language that if you learn one single language, you're pretty much going to gain access to the APIs, to the scripting APIs of pretty much every major CG application. So it's a huge bang for your buck. So this is the language to learn if you're just getting started in scripting. And number 10, Python is open source, which means that anyone can go and download the source code to build the language. What this means is that you could modify it and tweak it. It's not highly recommended because there's a lot of very smart people working on the main source code of the language, and they have engineered the language to be what it is. So if you start changing things a little bit around, then you might break compatibility with the rest of the language. So first step first, we need to get Python, and Python you can usually get it from python.org/download, or if you're using a Mac or a Linux machine, chances are you already have Python installed in your machine. So for now, you can go to python.org and download Python. If you're a Windows user, there's also another company called ActiveState.com that they offer a Python distribution that's a little bit more tweaked towards Windows, but either one of them will work under Windows, and it should work pretty much the same. And then the last thing I recommend is that you get a decent Python editor, like a true code editor. If you try to use Notepad or WordPad, you're going to have a very hard time following, because Python is it's a language where you really need syntax highlighting, and you really need an editor that understands the rules of the language. There's a long list of editors under this address right here. So you're welcome to go there and get one of the editors until, and install it while we get ready to move on. So let's talk really quick about Python syntax, and these are four things that we're going to cover over once we're in the interactive shell, but I just want to make a point before we go there. Python is case sensitive, so when I type something, and for example I have a capital P at the beginning and the rest of the words are in low caps, you have to match exactly what I type, because if you type it with a different case, Python will throw an error. It won't know what you're trying to do if you don't type it the right way. Another thing is Python is typeless. So you're going to see this really soon, but in other languages you have to tell it, when you're going to build a variable, you have to tell it whether it's a float, whether it's a string, whether it's an integer. In Python you don't have to tell it, because it figures that stuff out for you. So there's a lot less typing in Python. In Python, white space matters. In other languages you can have white space all over the place, it doesn't really matter. In Python it does matter, especially for indentation, because the blocks of code in Python are delimited by indentation. In other languages you use curly brackets. Python doesn't do that. You use indentation, and this is the reason why you need a very good code editor that can allow you to see these things. And then finally, comments are done by placing a number sign or a pound sign at the beginning of the line, and there's no multi-line comments. So if you want to comment out a whole bunch of lines, then you just have to put a whole bunch of pound signs at the beginning of every line. Alright, so let's now start an interactive session and see how things work. You can either start a shell and type Python, or you can start a program that's called IDLE, which ships with most Python distribution, but usually the shell is good enough. So I'm going to go over here. I have a brand new shell, and I'm just going to type in here Python. And there we are. We are now in the Python interactive shell. So now that we are inside of this interactive shell, let's go ahead and demonstrate some of the concepts that we talked in the previous slide. So first of all, let's look at comments. Right now, if I just go here and type, hi, this is a line, and I hit enter, Python's going to throw an error because it doesn't know what any of this means. You see, this is not in quotes, so it's not a string, so it's not, they're not keywords, so it doesn't really know what this means, and chances are that this was probably going to be a comment. So when you write a comment, you just put this pound sign in front of it, and you just type whatever you want. Usually comments are something that you write into the code to remind you or other coders what you were trying to do or what you're doing at this stage in the code. So if I do that and type, hi, this is a line, and enter, then Python just continuous and it doesn't throw an error because it's just going to ignore this line. So that's how comments are. If you need to comment a whole bunch of lines, like I said earlier, you're going to have to put a pound at the beginning of every line. Most code editors that support Python, they understand this, and they usually have a function where you can select, visually select with your mouse a whole bunch of lines, and then with a click of a button or a shortcut, it will comment out that block of code that you selected. So that's something you're going to have to look up. Next thing is that Python is typeless. So in other languages, if you're going to define a variable for a float, you would do something like float var, or v, and then you would do something like 1.2. Well, in Python, you don't need this. In Python, all you have to do is do v equals 1.2. And behind the scenes, Python will know that this is a float. And you can verify because if I do type v, it's going to tell me that that's a float. So these things are done automatically, and if I want to change what the value of v is to a different type of variable, I can totally do this. So I can do v equals high, and then if I do type v, it's going to tell me v is now a string. So this is what's known as typeless. The language is typeless. The language will figure out the types for you. So like I said, it's a lot less typing to do, but once in a while you have to keep your eyes open because the language is typeless. Sometimes it will do certain things that you haven't explicitly asked for it to do. So we'll cover those as we move forward. The next thing we need to cover is case sensitive. So if I do something like my var equals 10 and I type my var, it's going to tell me it's 10. But if I tell it my var, just one character is off and I hit enter, it's going to tell me I don't know what that is, because to it this one doesn't have any value. Actually, I can go ahead and do this, and now I have two different values. I have my var, which has a value of 2, and capital my var has a value of 10. So you have to be very careful when you type. Other languages are not case sensitive, but Python is. So for this reason, you also need to be, a little bit picky when you create your variables, because if you start mix and matching names, like if I go ahead into a script and I use these two variables, that they pretty much are the same variable, even though to Python they're not, but when you read them, they look very much the same. That's going to be very confusing for a programmer, even for yourself when you need to come back to this code sometime afterwards. So be very careful when you name your variables. And then the last thing is white space matters. So if I do, I'm going to do something really quick. So if I could do for I in range 10, sorry, I forgot this. And then I'm going to indent once and then do print I. And then I'm going to indent once more and do print by. If I enter, you're going to see number by number by number by. Pretty much for every iteration of this for loop, I printed first the number and then I printed the word by. Don't worry about this for loop. We'll cover that in one of the next videos. So I just need it for an example right now. But what happens if I do the same thing for I in range? And actually, let me make this a little bit smaller. And while I'm at it, I'm going to try to make the text a little bit bigger, easier to read. So if I do this and then I do print I, and then the print by, I actually take the indentation off, you're going to see the behavior is very different. So I'm going to go here, and you see right there it crashed. It crashed pretty much because it's telling me that this line of code is not in the proper indentation level, because it doesn't terminate the previous one. So chances are what you will need to do is do this, hit enter, and then if you wanted to execute the other line at the end, you would do this. So that's what I mean when I say the white space matters. In other programming languages, this code right here wouldn't really be an issue, because chances are right here where this colon is, and all the way at the end, you would have something like an open curly brace and a closed curly brace that tells the compiler, this is where my code begins and this is where it ends. In Python, you use indentations for that. So keep an eye open for those things. Also, it's very important to pick whether you're going to use tabs or spaces as your indentation, and most code editors allow you to select this. I almost always, pretty much always use spaces instead of tabs, and I always use 4 spaces for my indentation. This is pretty common out there, but you know, and I recommend that you follow this. But if you're going to go and start coding for a bigger studio, you're probably going to have to find out what are their coding standards for Python, because they might be a little bit different. Okay, so now that we covered these basics, let's start going some of the language features. So first of all, variable. We already did a variable when we did a equals 10, right? This right here, the word a, is a variable, and we have another video that covers all of this stuff a little bit more in detail, so I'm not going to reiterate on it. Just know that this is how you assign a variable in Python. In other languages, you can just do like you would do, like if you wanted to create a variable b, you would do something like float b, and then you could comment it out. You could end the line. Python doesn't really allow you to do this, as far as I know. Whenever you want to create a variable, you have to immediately initialize it with some value, so it knows how much space to allocate. And this is because it's not, it's typeless. So if you're going to create a variable, let's say called b, and give it a value of high, this is how you would do it. You give it the variable name, an assignment operator, which is equal, and then the value. Things to keep in mind for variables. Your names cannot contain any special symbols. So your variable cannot be named a plus b equals 2. That's going to throw an error, because plus is a special symbol. Also, they cannot start with numbers. So if I do 2a equals high, that's going to throw an error also, because you cannot start variables with a number. You can start it with an underscore. You can do this, and that is legal. And those are pretty much the only restrictions. So I usually tend to name my variables with it's known as camel case, where basically if I'm going to do a variable called this is my variable, I would type something like this, and then since is the first word of the next, is the first letter of the next word, I would go this is my variable. So you see here, basically every capital letter, it goes where a new word is beginning. So most programmers use this, and it's a lot easier to read. Some people, sometimes they use a different convention. They would use something like this is my variable. And in some languages, they would actually do like dashes. I think this will fail here. Yeah, because you have the minus. So like I was saying, those are pretty much the legal names. It can't start with a number. It can start with an underscore, and then you can put pretty much everything you want except for symbols in the name. Like I said, I usually start my variables with this camel case, like this one right here. This is my variable, unless I'm coding a constant. A constant usually will go all caps, like this is a constant. Or if I'm writing a class or a new object, usually that will be my class. That will always start with a capital. These are just conventions. It's not absolutely necessary that you write this way, but this is usually how I write. And a lot of people write this way. So you'll start seeing more of it as we keep moving forward. Next down, let's look at some of the operators. And the operators have different meanings depending on which value you're dealing with. So for example, if we did a value of a equals high, right, and then you did a plus a, usually in other languages this might fail, but in Python this means you're trying to concatenate high plus high, which is going to do high high. Or if you do a times 10, it's going to do high duplicated 10 times. So that is an example of operators that behave based on the kind of data that you have stored in your variable. If I do a equals 2, and I do 2 plus 2, well, it knows that 2 is a number, and probably what you're trying to do is arithmetic. You're not trying to do concatenation. So if you do, I'm sorry, a plus a was what I needed to do. And if I do a times 10, it will give me 20. Python supposes the most common operator, so you usually have minus, plus, divided, times, and then you have another operator that's called the modulus operator. Once again, I already have a video into the introduction to programming, the basics of programming, where all of this is covered, and Python pretty much covers and supports the most standard operators out there. So now let's cover really quick data types, and let's start by the simplest data types and move over to more complicated ones. The simplest data type in Python and in most languages is known as the Boolean, which can either have a value of 0 or 1. Those are the two values it supports. In other languages, you'll have the word true or false, which at the same time translate to 1 and 0. This is just for readability, but behind the scenes you can think of it as either a 0 or 1. So we can do something like q equals true, and in Python the true and the false start with a capital letter. If I do q equals true, and then if I do something like let's see how I can example. I can do something like if 2 greater than 0. Let's see. So what I did here is I did a quick comparison. I did if 2 is greater than 0. So that's going to return true, and that is equals to true, then it's going to print true. Now, this is not really good programming, because usually what you would do is you would do something like this, and then print 2 down here. This is usually what you would do, because it's the exact same thing. But I'm just trying to demonstrate that the value of q from now on is true, and if we do w equals false, w is a value of false. Something else that you can do is you could do q equals to 1 is true, q equal to 0 is false. And this is what I was referring to when I said that true has a value of 1 and false behind the scenes it has a value of 0. So if we do w equals 0, it's going to tell you that that is true. So you're going to use a lot the true and false data types when you're trying to do logic inside your programming, and every program out there has logic. So you're definitely going to see these guys again. Next down the list would be numbers. Python supports the most common numeric types. Usually in programming there's a distinction between an integer and a floating point number. Integers are usually whole numbers, so if you do q equals 10, that's an integer. If you do w equals 20.2, that's a float. So there are certain things that you have to be a little bit aware when you're doing operations, and this is common in pretty much every language. If you do if you add two integers together, like times 20, sorry, let's divide it. So 10 times let's do 20 divided by 7. Oops, sorry. If you do 20 divided by 7, because these two numbers are integer, the result is going to be an integer. I mean, even though the precision is not correct because the real output is not 2, it's going to round it up. It's going to give you an integer value. If you wanted to get the real value, you would have to turn one of these two numbers into a float. The easiest way to do it is just to put a .0, and then that will give you a true division. It's 2.85. So keep that in mind whenever you're doing operations between numbers, especially divisions. if you're trying to get a float value, you have to make sure that one of the two objects is floats, because otherwise the computer program is going to keep working in integers because it's a lot faster and a lot, it's just, the computer can do that operation a lot faster. So it always try to do what's fastest unless you specifically tell it that you're trying to do something. These are pretty much the most common number types. There's other ways you can store numbers, hexadecimal, and there's a couple of other notations, but these are the ones that you're going to be using most of the time. So that's all we're going to cover right now when it comes to numbers. Now we're going to cover strings. And strings in Python are really, really fun. In other languages, you don't have the vast amount of methods and tricks and things you can do with strings that you can do with Python, which becomes very, very, very pleasurable to work with, because a lot of times you're going to be dealing with text. So let's look at some of the different things about text. First of all, a string, can be thought of as an array in Python. Basically, it's an iteration object, it's an iterator. So a lot of the things that you can do on arrays or lists, you can do in lists. And this is very common for most computer languages. Most of the times a string is considered an array of characters. But Python, the support is a little bit stronger, so you pretty much have the exact same methods you can run on them. So enough talking, and let's cover some examples. So if I do q equals hello, what a lovely day. Oops, I messed this one up. Okay, so that's the value of q. And now I can do several things. First of all, if I do q, give me the value of 0, and this is how you're accessing it with bracket notation, which is how you access most of the arrays. That's going to give you the first letter, and if I increment this, you're going to see I keep getting the numbers of this string as I move down. Something else you can do with this kind of notation, you can select a range that you're looking for. So if you want to get q from character 4 to character 10, for instance, is going to give you from O right here to wa over here. So basically you're telling it with this colon, I want between this range and this range. A couple of other nice features, if you want to tell it from the beginning of the code, of the line, you can just do something like, don't give it a value here. So you can do q bracket colon and then where you want it to end. So when you don't have a value here, basically what you're telling Python is, I want you to give me the string from the beginning all the way to the 10th position in the character, and if I hit enter, that's what you get. You can also work things the other way around. You can tell it, I want you to start on the position 10 and give it to me all the way to the end, and that's going to give you that. Now if you start using negative values, so if I do q minus 1, it's going to do the opposite, where it's basically going to look all the way at the end of the string and it's going to start counting backwards. So if I do that, it's going to give you the last letter. So minus 1 is y, minus 2 is a, minus 3 is d for day, which was right here the last word of our string. So with this, you can also do something like, I want to get everything from the beginning all the way to the last letter from the back. And this is going to give you pretty much the whole string, so except the last 4 characters. So this bracket notation is known in Python as a slice, and basically it allows you to do very quick things. So when it comes to slices, we've seen that you can do pretty much, you can do q and then the beginning, the end, and then that's usually how we've been getting stuff. But there's one more thing that you can do, and over here is the interval at which you can get things. So let's see what happens if we want to get from beginning to end, but every 2 letters. So you're going to see it's going to skip every other letter, H, L, O, and then, you know, basically every other letter is going to be skipped. So when you think about it, it's kind of useful once in a while. For certain things, you can do it to just do it every 3 letters. But if you tell it to go from the beginning to the end and you give it a -1 as a range, it's going to flip your string. So this is a very quick way to reverse your string. There's other ways to do it, but that's something that is basically that you can do with slices. So remember, with a slice, you open bracket, you tell it the beginning, end, and interval. That's pretty much your format for slicing. You're going to use it a lot, and you're going to see me use it a lot as we develop more scripts. So let's move into the next thing. The next thing is length. You can always do len of q, and it will tell you how many characters are in that string. So this becomes very useful for many different reasons, and that's just one of the cool functions you have available. Now you see this one. This one is actually a function that works on any iterator type. That's why it's not a method that is part of a string. And I'm going to show you now a method for that. So for example, if I do q.find and I tell it I want to find w. So what this does is it goes into the string q and it says, okay, I'm looking for the letter W, and whenever I find it, return the first location where this happened. Excuse me. So the first location that happens is in this W right here, so it's returning 7. Just like that, let's say that I want to do Y. So it finds the first location that a Y was found over here. But there's another Y all the way at the end. So what happens if you're trying to use the last one? Well, you can use qrfind, basically right find, and that's going to give you position 23. So this function right here, these last two functions, they are actually method of the string class. And what I mean by that is that you access it through this dot notation. So you would do q dot whatever method, and then you'll have these parentheses which will take the parameters to that method. Whenever you're running a function, like an external function that's not part of the class, of the string class, you would run it like you run len. So you see there's a difference between this and q.find. This is an external function that just does its own thing, and you need to give it the data that you're working on. And this one right here is actually a method that's specifically designed and bound to the data that you're operating on. Let's keep looking on forward, and you'll get a little bit more used to it. Something else that you can do with strings, if you can tell Python to tell you if a certain string has been found inside another string. So for example, I can say the word lovely. So lovely in Q. And it's going to tell me true, because it did find lovely in true. But if I change this to double L lovely, it's going to tell me false, because it didn't find it. So this is a very quick and dirty search method inside a string. It's not that powerful because things have to match exactly the way you typed them, but it's useful enough. So it allows you to do that kind of thing. Another one that it's kind of useful is you can do q.upper, and that's going to turn your whole string into an upper string, or you can do q.lower, and that's going to do lower string. So what that allows you to do is, let's say that you were writing something that was looking for the word hello, and if you do something like hello in Q, well, that's going to fail because hello was, over here is capital H and down here is lower caps H. So usually what you can do is you can do Q in hello in Q.lower. So basically you're turning the whole string into a lower case. And this basically allows you to do search that is non-case sensitive. So if you run it that way, it will give you a true. What else can we do with strings? We can also do q.reverse. I'm sorry, I think it's reverse q. Let's see, maybe I'm doing something. All right, well, I thought there was a reverse function. I know there is one, and if you guys bear with me, I can go here and type Python string reverse. So let's see if they're, yeah, pretty much they're showing the way that I had done it before with the slice. And I thought that I had seen a reverse command somewhere. Chances are I saw it in another language because I'm constantly jumping from language to language. So maybe it wasn't there. Let's see something else. Okay, with strings, because strings are iteration objects, you can do something like a for loop on it. For I in Q, and then do a print I. That's going to print the whole thing one line at a time. Something else that it'll allow you to do, let's say that you have this word, you have this string, and you want to create a list of all the words that were found, where you can do q.split. The command q.split, what it's going to do is going to take every space in your string and it's going to use it as a separator, so that at the end you have a list where every object is a different object of that list based on the separator. By default, you'll use white space characters, but you can tell it what you want to separate on. So you could totally do something like q.split, and I want to separate by comma. So now you have hello and what a lovely day, because you told it specifically what to use for separation. Something else that you can do, let's see, you can do something like q.title, and basically this is title formatting for the text, where basically every first letter and every letter that's there by itself will be capitalized, just like you would do it in a title of something. So that's pretty much all I want to cover in strings right now. There's a lot of more things that can be done later, but just with what you've seen so far, you can see that we've learned how we can tokenize a string into a list so that we can iterate over it, and we've learned how to do an uppercase, lowercase, and a title. So with the knowledge you have so far, we're getting to a place where you can start doing some useful stuff. It might not be quite apparent at the moment, but we'll get there. So next down the list, let's look at lists. This right here is a list, this output right here, and we can actually capture that into a variable. So let's do w equals q split, right? And now w is this list. Well, some of the things that you can do with lists, also you can do len of w, and this will tell you how many elements was in the list. So remember, if you did len of q, this tells you how many characters are on the string, while len of w, it tells you how many elements are in each one of the, how many elements the list has. Just like we did before, you could do a for I in w, because a list is an iterator type. You can do that and print I. And that's going to print every word, every component of that list in an individual line. Something else that we can do, also we can do lookup by the bracket notation. So we can do w 0, and that's give you the word hello. If you do w0 to 2, that's going to give you another list that's based on this slice. And like as you can see clearly, slices work with any iterator type pretty much. So it works with a string and it works with a list. Just like that, you can do this every 2 objects, and then it will skip every other object. And then one last thing that I want to show you guys regarding lists. There's a whole bunch of other stuff that lists can do, and I think the best way to learn them is to just go through them as we're using them, because I don't think a lot of this is going to sink in until we actually get to use them. But one more thing that can be done, just like we were able to do q.split and turn a string into a bunch of elements in a list, there has to be a way to go back to string. So what you can do is you can do a string, something like a space, and then do dot, and then do the word join. And then what you're going to give it to the word join is you're going to give it a list, something like w. and then if you hit enter, that's going to basically reassemble a string like what we had before. So this right here, it might seem a little bit weird, but basically what you're doing is you're telling it that you have a string and you want to apply the string method to it. One of the things that Python allows you to do is it allows you to append a method to the return type of a function that you're calling. What this allows you to do is put things, basically chain commands together. So if we had q and it had that value, we can do something like q dot title. So that's going to give us a title, right? And then out of that title, we're going to take the last day. So we're going to do from -3 to the end, right? -3. And then since that is returning also a string, I can do that and do upper. So you can see we're concatenating different operations here. Here we're returning to a title, then we use a slice, and then out of the slice we do another dot to run another method on it. So this is something that you can do with Python, a lot of other languages, but in Python it's just quite a lot. So we looked at lists. Now let's look at tuples. Tuples are similar to lists, but instead of using a square bracket, because that's usually what you do with lists, lists are usually done like this. 1, 2, you can do 1, 2, 3, 4, right? That's a list. A tuple uses parentheses, so 1, 2, 3, 4. The difference is in a list, I can always go W, element 0, I want it to be now 10. And if I hit W, the first element is now 10. A tuple, once you create it, it's basically a constant. You can't grow it and you can't change it. So if I do E0 equals 10, it's going to throw me an error because it does not support assignment. If I do something like W dot append and then do a 6, do W, you see we appended a 6 to the list W because lists are mutable. They can change, they can be reassigned, and they can be grown. A tuple is not. I can do E dot append 6 and it's not going to work. And actually I'm going to show you guys something that's really cool about Python. You can use a function called dir to examine any particular type. So if you want to see, okay, what is supported by Q, you can do dir Q and then hit enter. And these are all the classes that are supported by the class Q. You see right here, there's a whole bunch that have underscores at the beginning and at the end. Those are usually internal objects and you do not want to mess with them usually. You just want to leave them where they are. But every one of these ones, like capitalize, center, count, decode, encode, ends with, expand tabs, all of those are functions, and we've used some of this. Find, rfind, any of these you can use with this notation. So you can do q dot title, just like right there, q dot title, and it will run. Now the other cool function, so not only do we have dir for q, which gives you all of the functions, you can also do something as help q dot title. And what that's going to give you is going to give you if the author of this library or of this class properly commented everything, this will give you some documentation on it. So you can see right here, it's telling you help on built-in function title, and it tells you title, you just call it like this and it's going to return a string, and then it tells you return a title case version of S, and then to get out of this, I believe you just do colon and Q. So those two, dir and help, are really useful while you're working inside your shell and you're trying to figure something out. You don't know exactly what is supported. You can do very quick introspection into the variable that you're dealing with by using either dir and help. So those are tuples. Tuples are like lists, but they cannot change or grow. And then the final thing that I want to cover is dictionaries. In other languages, this is called a hash map. In Python, they're called dictionaries. And dictionary, they can be thought of as a list, but a list is usually an ordered, it's a list of ordered elements. So W has that, you know, and then if you want to get any of the elements in here, you can only get them by their position. But what if you wanted to store an object that had a whole bunch of different values and you want to be able to get them back by a keyword? That's where you would use dictionaries. So if you use something like R equals, and dictionaries begin and end with curly braces, you would do something like name, and then Rudy, comma, last name, Cortez, age, 35. Actually 35, we can leave it as a number. So if we do this, we just create a dictionary where basically you have this key and value pairs that have been stored, and you can see as soon as I try to call R, it already kind of moved things around, so they're not in order anymore. But it's very useful for me because now if I wanted to get the age, all I would do is R age and do this lookup, and it will give me 35, and it actually returns a number, not a string. If I do R.name, it gives me back the word Rudy. Once again, because what it is returning now, it's a string, I can just do something like so now we can do R and then look up the value for the key name, and because this is a string, you can also call like I did before, you can do something like capitalize, or you can do, actually capitalize the same thing, you can do something like upper and it will give Rudy in capital letters. So this is a dictionary, and like I say, in a dictionary you can do something like r.keys, and that's going to give you all the keys that are in this dictionary, and you can do r.values, and that will give you all the stored values. So dictionaries are really useful when you're trying to store data that you need to get quick access to it, and data that you need to look up by a very specific key. It's not just ordered. So if you're just gonna, let's say you are writing something that is gonna export objects, and you don't really care the order of the objects or something, you can definitely have a list that is you know, object A, B, and C. You know, and that will just give you a list of objects. But what if you actually want to store some of the values of the objects? Then you would have something like a list, and then inside the list you'll have a dictionary, and this could be like name, and then we'll do A, size 22. So let's say you're storing that, and then you can do obj, and then here's where you would store the link to the actual obj, so object. So this could be like let's just do q and pretend that that's a value. So, and then for the next object you will do the same thing, name. The name is probably going to be different, so it will probably be B, and then size, and actually this needs to be quoted also, I forgot it over here. So size, this one is 10, and then obj, let's say that this one is, actually, you know, for object we can actually use a Python object we have. For this one we're going to use Q, and for this one we're going to use W. This will probably be an even better example. And instead of using size, we're going to do len of W. Name, we're just going to keep it B, and then len of Q. So we're going to store this in another one called A, right? Let's see, I forgot something here. Obj, that should be it. So now the value for A is this list, and this list contains several dictionaries. And here I think you can start seeing how powerful this can get. You can get a list that holds a dictionary, and that dictionary, one of the elements can be another list, and that list can be a list of dictionaries. So you can build these huge data sets that allow you to move data around and look things up really quick. So if you do something like A, and then you want to get object, let's say you want to get for a value of 0, you want to get the obj, right? So if you remember, the first element of A is this object right here, and then the value obj was actually hello what a lovely day. It just took the value of the string. You could always also do this, A1, and it will give you the values of W, which I believe was that. And just like that, you can do Q A of 1. Instead of giving the obj, you can get the name, and that's going to be B, and you can do A0, and that can be A. So this, and actually the size would also work. You should be able to have the size 24 of A0, and if I do len of Q, oops, that should match 24. So there you have it. These are the most important data types inside of Python. There's other ones out there, and there's other ones that you can build, but these are the core ones, and as you can see, they're very powerful. You can put together a lot of stuff that you might need. It's probably not quite apparent right now. We're going to move over to the next video, and then you're going to start seeing some more interesting stuff. So for now, that's all I have for you guys, and see you on the next video.